All right, so just look up on the board here, guys. You don't need to write anything down, but I think this question will help us battle the fiasco of, remember the end of the lesson yesterday when I was like scrambling and trying to hurry up and answer that question properly? And Daniel was totally right with his equation setup, and I was just having a heck of a time verbalizing why he was right. I eventually figured it out. I recorded it when you left. So let's talk about this question, and maybe it'll make a little more sense. Because this, even though it's cute and it's about elves, this is actually a really hard question. So Santa's elf, one of his best elves, Buddy, was making toy cars and dolls last night. Elves are paid to make toys. He's paid $1.50 for each car and $4.50 for each doll. He made a total of $75. He produced 3 times as many dolls as cars. So, first, what variables would you like to use? Okay, let me guess. D represents, what about dolls though? Number of dolls, thank you. And C would represent the number of cars, I'm guessing. So there's a bunch of money clues here that we can put together into an equation. So $1.50 for each car, so that would be $1.50C plus $4.50D, and a total amount of money for Buddy was $75. That's not the equation I was worried about. This is the equation I'm worried about. He produced 3 times as many dolls as cars. So for most kids, when they look at that, they're just used to directly translating their algebra, and they write this: 3D equals C. And that's really, really wrong. Because when you set up an equation, you need your equation to be balanced. So interpreting that statement, he produces 3 times as many dolls as cars. What does he produce more of, dolls or cars? Dolls. He's producing many more dolls than cars. So for me to create an equation that says that, you actually would have to triple the amount of cars to equal the number of dolls. So it's a balance game. So tripling the amount of cars would equal the number of dolls he creates. That is really hard for kids to catch as they're reading through a word problem. So here's some ways that I look at that I can kind of figure it out. First of all, I'm just going to flat out warn you, there's one of these on your test. It's the only story problem that's like this, so just know when you get to it, there's a sneaky part to it. If I don't see the word is, that means you don't have a direct equation. So like if it said, the number of dolls is, that's a direct equation. Do you notice is not anywhere in this sentence?
He is.
No, this sentence. He produced 3 times as many. So there is, or the past tense was, is not in that statement. So that tells me, I got a tricky equation that I got to work at balancing. So basically it's a backwards equation. To review what we did yesterday, like maybe you've decided after yesterday you are never again going to solve a system of equations by hand, ever, ever, ever. What if you wanted to use your matrix RREF on this question? You could, but you got to set up as an augmented matrix first. Which one of these equations is not quite ready? Yeah, that blue one. Can you rearrange it so it looks like the green one? Yeah, 3C minus D equals 0. So that's what we did yesterday. Like, forget that. We're going to do this. And then we'd enter our augmented matrix as 1.5, 4.5, 75, and 3, -1, 0. And then we're going to do a lot of typing today, so I'm going to kind of save you some time. But if you did do RREF on your calculator here, don't bother typing this, guys, because we're going to move on in a minute. You're going to end up with this. So now, what I think is probably one of the most difficult jobs of working with matrices, interpret that for me. What does this say? He made... What does this mean? 5 cars, good, and $15. I'm like 99% sure that's the right matrix that you get at the end. I just did this problem with first hour, and we did so many matrices problems that I kind of forgot what the answer was, but I'm pretty sure that was the right answer. I should go back and look at my slides. Apologies if that's just flat out wrong. Okay, so the tricky part of that question was that blue equation, and there will be one on your test like that. All right, real quick warm up. Find, I'm going to change this question a little bit. I'm just going to have you find A times B. This is on worksheet 10. And while I know you guys do have the capabilities of typing this in your calculator and just multiplying them that way now, let's do this by hand anyways, because number one, I would argue doing this by hand is actually faster than the calculator. And two, if your teacher, which she totally is going to do this, throws an algebra component into your matrix, you no longer can use the matrix on your calculator. So in order to multiply matrices together, you have to check the dimensions. This is a 2 by 2. This is also a 2 by 2. So if I was to multiply A times B together, first I check that we can multiply them, which we can, and the resulting matrix is also a 2 by 2. So what I need you to do on your paper is go ahead and write a blank 2 by 2 for me. And then this is where we busted out the colors if you have them. You're going to circle the rows from your first matrix, so matrix A. Try not to cross them off like I just did. And then circle your columns from matrix B. And then this is the fun time where you get to multiply and add together. So goldfish memory teacher here, I'm going to rely on you young people and your good memories. You ready? So I'm supposed to be up at the board pointing, but I'm pointing at the first row and the first column, and we multiply 2 times -1 and we get -2, and then we add it to 0. -2 plus 0 is, thank you. I'm going to move over to the first row, second column now. So staying with my first row, but now my second column, I got 2 times 5, 10, plus 4 times -2, -8. What's 10 plus -8? 2. All right, now I'm on the second row, first column. -3 times -1 is 3, plus 0 is 3. And now we're on the second row, second column. -3 times 5 is -15, plus 2, -13. There's the resultant matrix from your multiplication. Now, if they asked me to multiply B times A, you could do it, because it'll still be a 2 by 2. It's going to be a completely different matrix. So for the sake of time, I'm just not going to do that if you guys don't mind. Move along. Okay, finally, we're going to see some examples of how, this is a bit of a lame example because the real life ones are really hard to look at for a new pre-calc brain. But this is a simpler example and something they actually do use. So we have 3 figure skaters, Holly, Joelle, and Louisa. And they are going into some competitions. They're judged on their skating skill, choreography, and interpretation. So depending on which system of judging they use, certain skaters are kind of valued in one system better than the other. So rather than calculating Holly's score in both systems separately from Joella's, separately from Louisa, since they're all working at the same systems with the same scoring methods, we can just take these, write them as matrices, and multiply them together and make the calculator do all of the multiplication for us, and then we can interpret it from there. So what I need you to realize, a couple of things the way they have this set up. So we got Holly, Joelle, and Louisa. They're written as rows. So I'm going to call this my first matrix, and Holly is her own row, and Joelle is her own row, and Louisa is her own row. We're going to enter this matrix into matrix A on our calculator. And similarly, we have another matrix that takes those same criteria in the same order, S, S, C, and I, and it compares the two systems. So we're going to take the columns of these two matrices, of this matrix, excuse me. So this is matrix B. And what we're going to produce on our calculator this time is matrix A times matrix B. There's no sense in us doing this by hand. The fact that this is a 3 by 3 and this is a 3 by 2, that tells me, yes, we can multiply them, and the result is going to be a 3 by 2. So I'm going to pause the video while you guys type for me, and you're going to find this resultant matrix that represents the scores that each lady will get in each scoring system. So the resulting matrix looks like this, but again, interpretation is kind of the key. So you think about what we did here. We took the rows from the first column, so that means the rows of a resulting column represent those rows. So this is Holly, and this is, what's her name, Joelle, and this is Louisa. And then the columns of the resulting matrix were taken from the columns of the second matrix. So this is system A, and this is system B. So when I want to know, when I'm looking at Holly's scores, which system does Holly's skating style benefit in? Is it system A or B? Where does she score higher? In, I think it'd B. She scores a 4.2, doesn't she? There we go. So then for Joelle, she scores higher in System A. And Louisa, she's going to score higher in System A as well. So maybe that determines which competitions they actually enter based on how they're scoring, or maybe they just suck it up and become better skaters. I mean, whatever. Gosh, girls. All right. I know, really cutthroat, wasn't it? All right, little bit of vocab coming your way. The next concept is called the identity matrix. We kind of saw the identity matrix yesterday when you guys did RREF, and you saw a bunch of ones along the diagonal with zeros everywhere else. That is essentially the identity matrix. If it's alone with no solutions off to the side, that is the definition of the identity matrix. So it's going to have ones along the diagonal and everything else has to be zeros. The reason the identity matrix would show up in your math is because you've successfully undone a matrix. This is a hard thing for kids to understand. A matrix is a function. It's a series of functions, actually. So just like tangent and sine and cosine, you can't divide by a sign. You can undo a sign. And that's what we have to do in matrix land as well. We have to undo the matrix. So we're going to be using inverse matrices in a moment. And we're going to produce the identity matrix. And that's how you know that they've undone each other. It's good times, right? We are not going to make you do matrices inverses by hand. Now you have the capabilities to find them on your calculator. So I don't care what you have on your calculator right now. I want you to go find the matrix inverse of whatever matrix you have. So I'm going to pull up any old matrix that I happen to have entered. Matrix A, for me, is something totally different from you guys. But if I said, hurry up and go find the inverse of this matrix, I don't have to do it by hand anymore. I can just pull up that matrix, and then I can use what's called the inverse key that you guys always know how to use, that guy. If you hit enter, that's the resulting inverse matrix. Now, you guys have a totally different matrix than me. I know you're all like, wait, what? Because you have that ice skating problem in right now, right? Yeah, you got weird things. If you hit math enter, it'll bring them to fractions. Which looks a little better. There's a zero out there, huh? And if you ever get like an error, that means the inverse doesn't exist, which is okay. That happens sometimes. So from henceforth, if you guys have to find the inverse of a matrix, you no longer have to do it by hand. You can always use the calculator, okay? I'm actually not going to ask you to find the inverse. But here's what I am going to ask you to do. I'm going to ask you to determine whether or not two matrices are inverses of each other. So here's the definition of how we know they are inverses of each other. If you multiply the matrices together and they undo each other and you get the identity matrix, that means they're inverses of each other. So now I do need you guys to do a little typing. Could you please type in this guy into matrix A and this guy into matrix B? And I actually do have this one typed in, so I'm going to pause the video while you guys are typing. So once you have matrix A and B entered into wherever in your calculator, but mine are in A and B, they're both 2x2s. This is how you verify or prove to somebody that they are inverses of each other. You multiply A times B and see what you get. And then you multiply B times A and you see what you get. So A times B, I'm going to pull up A and then times, and now I got to pull up B. There's probably a quick key for doing this, but I don't know what it is. Hey, looky there. What'd you get? You got the identity matrix, where ones are along your diagonal and zeros are everywhere else. So that proves to me that A and B undid each other in that case. However, you do need to flip them around and do the other order of multiplication. It should be the same thing in this case, but you still need to verify it. So B times A, where are we at? Matrix A, which also produces the identity matrix. So there's going to be a question in your future that says verify whether or not these are inverses. And the easiest way to verify or show somebody yes they are indeed inverses is to say A times B and B times A both produce the identity matrix. Voila, inverses. Now, someone asked me before, what if I just typed in A and then I hit A inverse? Go ahead and do that, guys. Go find the inverse of A. I bet it's B. It is. Okay. So, technically speaking, you can find the inverse and just be like, yes, it's the inverse because I found the inverse and that's the inverse. That's just a little hard to explain, and justify in your writing. I think it just sounds more mathy if you say something about them producing the identity matrix when you multiply them. I'm just throwing those out there. All right. We're going to skip around on some things here. No to that. There, yeah. Oh, by the way, when you multiply 5 together, don't do this because it's right here. When you entered A and B for number 5 and you multiply them together, did you get the identity matrix? Right. That's a big no. So are these inverses of each other? No, they don't even come close to undoing each other. So no, those are not inverses. And your reasoning would be, when I multiply them together, I do not produce the identity matrix. Aha. All right. So on these questions, and when these show up in your homework of find the inverse, if it exists, you don't have to do them by hand, guys. You can just do them on your calculator now. So you can go back and do them by hand. We had that formula that we learned, but you guys don't have to do these. We're going to skip ahead for the sake of time. All right, here we go. Here's another new thing. This is not on your notes, but we're on the back of your notes right now. So one of your questions on your test on Friday and on your post-test next week is going to say, can you take a system of equations and can you write what's called a matrix equation? So this kind of feels like what we did yesterday. Yesterday was called creating an augmented matrix. A matrix equation is a little different. So it peels off just the coefficients of the body of your system. So the coefficients in front of the x and the y and the z or whatever you have. And then it multiplies it by the variables that you're using. So in this case, it was x1, x2, and x3, but we usually use x, y, z. So the variables in that order show up in the next matrix. And then it equals this last matrix, which I'm going to call the solution. So these would be the solutions to all your equations in the original setup. So one thing you got to do for me Friday is take a 3-variable system and peel it apart and write it as this matrix equation. So there's some questions here on your notes. This one's already kind of done for you, so this would be a good place for you guys to write down some notes. Here's your system of equations, and notice what they did first. They created the first matrix A. These were your coefficients. Then they multiplied it by this matrix, this 2 by 1. These were your variables. And then it equals this last matrix, which would be the solutions, or the answers. That's what it looks like to create a matrix equation. So that'll be one question on your test. Can you create a matrix equation? Now, this is where we're going to kind of divide and separate. You can solve this new way that I'm about to show you. So think about what we have here, guys. We have matrix A times this x, this variable matrix, and we have equals matrix B. And I'm trying to solve for this variable matrix because I'm trying to find x and y. So I need to undo matrix A. And a lot of kids say, oh, well, easy, just divide it over. Remember, matrices are not numbers, they're functions. You can't divide them. So what you have to do is you have to undo them. Well, what would undo matrix A is the inverse of matrix A. So what you're going to do is you're going to apply the inverse of matrix A to the left side of the equation. But the rules of equations state that if you do something to the left, you have to also do it to the right. But here's where it gets tricky. Matrices, you have to put them in front here. So this A inverse goes in front of matrix B. So on the calculator, to get this right, you could type in matrix A and then type A inverse times B. And that is one way that you will produce the answers for x and y. Or you could go back to yesterday. How would you have solved this yesterday? Go back way to the original problem. You would have set up an augmented matrix, and that would have looked like this. 3, -7, -16, -1, 2, and 8. And then you would have done RREF. And you would have gotten the answer this way as well. So this is where it's your choice, guys. I am going to make you create the matrix equation because that's one of the skills we need for pre-calc and eventually for other math. But whether you use that matrix equation to actually go through and solve it is up to you. I'm going to be honest. I never use A inverse B when I'm solving these. I always use RREF. I feel like it's less typing. I don't know. It's probably not less typing. I feel like getting in and out of the menu is just annoying. So I prefer the augmented matrix method. But just for funsies, can you guys do this one with me? Can you please type this blue matrix into matrix A? And can you type this green matrix into matrix B? This is a 2 by 2 and this is a 2 by 1. And then I want you to type this on your home screen once you get everything entered. I'm going to pause the video while you guys are typing. So class tells me to get negative 24, negative 8. So that's another way to get the solution, A inverse times B. If you flip that order around or you do the wrong inverse on the wrong matrix, you're going to get it wrong. So you have to just be careful that if you're choosing this method that you're practicing it this way before you get to your test on Friday. But like I said, if you want to go back to your roots and do RREF on the augmented matrix, you're welcome to. All right, so let's take a look at some examples that are not done for you. And I really just want to practice you guys writing the matrix equation. That's the important part for us on this lesson here. So for number 7, the matrix equation, first you'd peel off the coefficients and create that matrix. So we got negative 2 and 5, 3 and negative 1. Make sure the order is always good before you get started. You're going to multiply it by your variable matrix, which is in that order, so xy. Messing up my colors all of a sudden. And it's going to equal the solution, which is 24, negative 10. So one skill I need from you, can you take a system and can you create that guy? Now, this is where maybe we separate. Choose what method you'd like to practice right now. If you are going to do A inverse B, that's fine. Go ahead and type them in. If you are going to do augmented matrix RREF, that's fine. Either way, we should all get the same answer. But I'm going to need to steal your answer because I didn't actually solve this. Negative 2, 4? That was it? Okay. And you should end up with the ordered pair for xy negative 2, 4, I'm hearing. Okay. So maybe today you switch it up. Maybe you try one the inverse way and one the RREF way and then make a decision before you start your homework and, finish your homework tonight. Tomorrow's our last lesson? That's it. Oh, man. That's a look of joy happening over there in some people's faces. Okay. All right. Can you guys help me? Now, be careful on 8. That second line, I think, might trip some people up. Let's peel this apart into a matrix equation. Your coefficients are 1, negative 1, 2. What's the coefficient line on the second one? Ah, good call. 1, 0, negative 1. And then your third line is 3, 2, 1. So there's your coefficient matrix. We're going to be multiplying it by your variable matrix, which in this order goes x, y, z. And then it equals the solution matrix, which is, in that order, 5, negative 4, 0. All right, to save you guys a little bit of typing, don't bother answering this one. You would choose your method. You do A inverse B, or you could do RREF on the augmented matrix. It is up to you. All right. Feel like you got enough to get your homework done? Very short assignment out of the book for this stuff, guys. Real short. 1, 2, 3, 4, 5 problems? I guess. Wow. All right. Well, there you go. All right, could you please find worksheet 12 next? We're going to look at the back side of worksheet 12. And this is an intro to tomorrow, our final lesson. And it's about cookies. What a great ending to our lesson. We started with elves and we end with cookies. Now, the fact that this question literally takes up the entire page, that should tell you something. The fact that I'm stopping you about 17 minutes before the end of class to do it, that should tell you something. This is an elaborate question. This is the intro to what's called optimization, or linear programming, is where the root of this starts. And it's based in application, so that's kind of cool. This particular one's a little lame, because I don't know if bakers would go to the extent to do some math to figure this out, but, maybe. Businesses use variations of this idea quite a bit, because a business's job among many things, is essentially to maximize their profit and minimize their cost. So they will go to great efforts to have somebody come in and consult with their company and figure out how can we maximize profit and minimize cost. Also without killing our workers. That'd be good too. You know, they don't want to, yeah, right? They want to make sure their workers are safe. So there's natural constraints that occur in this problem that are obvious. Like when I ask you how many cookies can you produce, you can't produce negative cookies. Okay? Well, we're not going to claim we can produce negative cookies. So you'll notice in the graph that's down below, it doesn't show you any negative parts of the axes because that's just like a duh moment. Like, no, we're not going to go negative. But there's some other constraints that Jack and Jill know about. They're going to make plain cookie boxes and iced cookie boxes, and it says right down here that you're going to use X for plain cookies and Y for iced cookies. So keep that in mind. So the first set of constraints, restrictions that occur, is one box of plain cookies requires 1.2 pounds of cookie dough, and one box of iced cookies requires 0.9 pounds of cookie dough, and Jack and Jill have 72 pounds of cookie dough. So we're going to be able to set up not an equation this time, but an inequality that represents their restrictions based on just how much dough they have. So 1.2 for every plain box of cookie, and then 0.9 for pounds for every iced cookie box. And they have up to 72 pounds of dough. So what mathematical symbol would represent that situation if it's up to? Less than or equal to 72. Nice call. Now, icing, plain cookies don't have any icing, so we don't have to worry about that. But the iced cookies requires 0.4 pounds. So 0.4 Y, and they have up to 20 pounds. So again, we're going to use that less than or equal to 20. And then time. Of course, there's a natural constraint of time. There's only so many hours in the day for these people, you know. It takes them 0.10 hours to prepare a plain cookie box, so 0.10x. And then 0.15 Y for the iced cookies. And they only have 9 hours. So that's what they have to work with. All right, our next task is probably the most annoying one. We're going to have to graph all of these inequalities and create what's called a feasible region. It's going to look like an inequality section. I don't really like the way they look for graphing. I really would prefer these all to be solved for Y. So what I need from you guys is I need you to get Y isolated. So like for instance on this one, you're going to have to subtract the 1.2 and then divide everything by 0.9. So I need some calculator help here. Could you please tell me what happens when you take negative 1.2 and divide it by 0.9? And then math enter that because I think it's a nice fraction. Negative 4/3, cool. So your slope is negative 4/3 x, and then over here you would have also divided the 72 by 0.9. I think you get a plus 80 on the end there. So I'm just rearranging that blue equation for y. I'm not showing a lot of that work, but you're pre-calc, we got this. All right, this next one, you're going to divide both sides by 0.4, and you get y is less than or equal to 50 is what we're really going to graph. And then this one, I'm going to need some calculator help again. I need to know what happens when you subtract 0.1 and then you divide it by 0.15. Negative 2/3. And then what happens when you take 9 and you divide it by that 0.15? 60. Cool. All right. Here's the challenge. We got to take each one of these inequalities and we got to graph them. So good news is every one of them is a solid line, so I don't have to worry about weird dashed line business. We're going to be shading underneath all of these lines, so what you're going to see is a very naturally forming quadrilateral is what we're going to end up looking at. All right, let's start our graphing process. The blue line starts up here at 80, that was the y-intercept. And then his slope, I believe, was negative 4/3. Now, I know these blocks are not counting by ones, but the ratio would be the same, so I'm just going to always count slope in terms of the blocks. So I'm going to go down 1, 2, 3, 4, 1, 2, 3. And you know I can't graph, so I'm just going to kind of keep going. And then I'm going to ruin it by trying to graph. Yeah, so close. Almost. So close. Don't shade yet. We don't want to shade yet, but we know we're supposed to be underneath that line. Now, the other constraint, the one that was about icing, that was the line y is less than or equal to 50. And that one should just be a straight horizontal line over here at 50. So again, we're going to be graphing underneath that line too. I'm just not going to do it yet. The other constraint was the time. And once you guys rearrange that one for me, we started at 60, and then we had a slope of -2/3. So starting up here at 60, I'm going to travel down 1, 2, right 1, 2, 3. And again, I'm supposed to... now, if I was super awesome and accurate all the time on my graphing, I probably wouldn't have such a hard time with these questions. But if I'm graphing underneath all these lines, maybe you see the shape forming. It's this weird little quadrilateral thing. Yeah, close enough is kind of my motto right now. Yeah, it is. Okay. The space within that shape is actually not important to me. What's important to me is the maximization points occur on the vertices of this shape. So like right here, there's a critical point, and right here, there's a critical point, right here, there's a critical point, here, and here. And 4 out of those 5, I think I pretty much, oh, it's not a quadrilateral either. Whatever shape this is, this weird polygon. 4 out of the 5, I think I can clearly identify even on my crappy graph. This one right here is the tricky one. So I'll tell you how to find this one in a minute. But this is 0, 0. So I'm going to write that down, 0, 0. This one over here is 60, 0. I'm pretty sure this one's 30, 40. Your graphs are probably nicer. Does yours look like 30, 40? Okay. This one I'm not real sure about. I'm going to come back to that one in a minute. And then this one is 0, 50. All right, let's talk about this point of intersection right there. I know for a fact that it's got a y value of 50. But I'm not real sure like how far over that is. But I know it's where it crosses the green line. So if I go back to my actual equation, and you can do either version of it, if you know your y is 50, so either here or here, I need you to plug in a 50 there and solve. So real quick on your calculator, guys, we're going to have 50, so that means we would subtract the 60 over. So 50 minus 60 is -10. And then you'd have to multiply it by the reciprocal, right? So multiply by -3/2. And you get 15. 15, yeah. So that ordered pair came out to 15, 50. So once in a while, if you graph like me, you might have trouble figuring out where your critical points are, where your vertices are, because you don't graph so hot. And you gotta rely on your algebra to find where they intersect, which is fine. All right, so one more part to this problem. Let's talk about money. They know how much money and profit they make off of these cookies. So they make $2 off of the plain box of cookies. So profit is found by $2 for every plain box and $3 for every icing box. This is how we can calculate how much money they're making. What we need to do, though, is go back to those 5 ordered pairs that we just found and figure out which one of those situations will give me the most money, because that's what I want. I want to make a lot of money. Yeah, well, Adam, that one's silly, isn't it? How would you expect to make any money off of making nothing? You make no cookies, you make no money. 0. Now, if you were to plug in 60, 0, so plug in a 60 for the x, you'd be making $120. Great, I might need some calculator help. My brain's kind of fried right now. If you plug in a 30 for the x and a 40 for the y, do you get 180? Okay. If you plug in a 0 for x and 50 for y, you get 150. And then is this 180 as well? Okay. So what do we come back to Jack and Jill with? What do we tell them? Now they want to make the most amount of money. Turns out they have a choice. So I guess it's up to them. Maybe they need to think about their customers a little more. Would it make more sense for them to produce 30 plain and 40 iced, or 15 and 50? So those are the options that we give to our business. Say, here's how you're going to make the most money. And what is their profit that they're making, by the way? Which number there represents how much money they're making? The 180. So you're going to maximize your profit at $180 by either making 30, 40, or 15, 50. All right, so on the front of that worksheet, that's going to be what's part of your homework. So there's a very similar question. This time it's about little toy cars. And wheels and seats. What a wonderful question for you right before Christmas. Thinking about making all those little toys, just like Buddy's problem. So you're going to finish worksheet 12 for homework, and then you also have, like I said, I think it's 5 questions that you're doing for me. Remember, if at any point you're going to your calculator, you need to write down like the augmented matrix of what you're typing in your calculator for me, guys. Okay, don't just copy the answers and walk away. Remember, this test on Friday, it's probably a one and done for everybody because you're just going to run out of time, y'all. Because once Friday's over, we got to start rocking and rolling on our post-test.
Is it a whole day next week or just a few days?
2 days of review, 2 days of testing. Yes, we do. I'm not sure what we're doing with the 5th day yet. I like to leave a day for what if there's a massive snowstorm. Like, I don't think there's going to be. But we like to build that in. Because the minute we don't build that in, we get a massive snowstorm. No, it's like too warm. Climate change, man. You're just getting rain for the rest of your life, I guess. I'm fine with all the rain. 15 we're looking at, and it's really confusing because it says it's, let's see, be the number of cakes, but then they flat out tell you the number of cakes. I don't think that's the number of cakes at all. I think it's the cost of a cake. That's what I think it is. How confusing. Right? Alright, we'll come back. So thank goodness a friend asked that question because this last 2 equations that we set up originally are actually kind of tricky. This one said something about the pie being, how did they word it? A pie costs $2 less than a cake. So that equation wasn't too bad for us to set up, but this is the one we were worried about. It says that a cake costs 5 times as much as one of those giant cookies. So in order for us to get them to equal each other in price, we have to multiply the giant cookie by a 5. So that was the question we were worried kids wouldn't set up right. So these bottom 2 equations weren't in the right order for the augmented matrix. The top one was fine though. So once we could kind of rearrange things and write everything up, Jeepers creepers, nothing's working. Once we can write it in this form, we should be able to come up with an augmented matrix here. Whoops. And then we're going to use RREF. Apologies in advance because I have a feeling I just made a mistake on a negative sign, but y'all will figure it out. All right, good luck.